Good afternoon, this is Mark Young and we're in the studio today and I'm going to show a couple of small repairs that would normally be done in a home or on a farm. And over the next 3 sessions, I'm going to start a blacksmithing session. We'll look a little bit today at some of the tools, some of the equipment. I have some forges and several anvils that I want to show that this will be set up in about 2 weeks. So I have a set of fireplace andirons that someone brought in and donated. And even though I don't have all the pieces, this is a pretty typical break in cast iron or wrought iron. So I'm going to go over to the wheel and clean up both pieces and then come back and braze them together to show how to do a pretty basic repair. Almost like a broken leg where you put it back together. So I'm going to do that now. All right, now we're at the grinding and buffing wheel. This is a machine that's made by several manufacturers, and in the knife industry where they make custom knives and different high polished works. Typically you would have 2 wheels. One is a cut and a color wheel, and they're used for buffing down, just like in sandpaper. You go through different stages and the polish gets higher and higher, and the finish gets more like chrome, if you've seen polished chrome. On this end is a wire wheel. It's pretty typical in the business of metalworking, and it's used mostly for taking down surface rust and scale when you do things. So since we're going to do a little repair this morning, this particular piece, as you can see, has been sitting outside for quite some time. So I'm going to take this joint and clean it up, and then the piece that's broken, and clean those, and then we'll weld them back together. So I'm going to turn it on. And that is the area that's going to be welded. It is now back to bare metal, and this part is ready. And that's what you have to do. If this isn't clean, then the brazing and welding won't work. Doesn't always work, but it won't work. Okay, now this is the other section. And that's the actual broken part, just like in a leg. It's just broken at a different perspective than it originally was formed. When you put this back together, if it's done correctly, there's about 50,000 pounds of tensile strength if it's done right. And that means that that should never break. And this could break again, but not the joint. So now I'm going to go back over to the welding table and put these together, and we'll repair them. Now, this is the area we just cleaned, and on a lot of the earlier andirons from the 1600s, they were actually made by a blacksmith. Some were English, some were made here, some were German, and you would never see a bolt. This tells me that this was an inexpensive set, and it was probably made in the 1950s or 60s, I'd say, by the styles. This is brass on the top, and this is cast iron. But that's a machine screw, and that would not have been available when the older pieces were made. But it's still a repair, and I think that's the part that, so the idea is to get it to sit without falling. That's the trick, to line the joint. and then I'll try to tack it. Okay, this will pop. Now, when you start, if you're working with a torch, you want to, this is your acetylene flame. You bring your oxygen on, and it reduces the feather down to the cone. And you'll hear the hissing, which will tell you the heat. All blacksmith, all metalwork, no matter what instrument you're using, is done with temperature and a color. And after a while, you learn the color of the item that you're going to repair. Some items, if you go too far, will fall apart. Aluminum, some of the other softer metals, if you get them too hot, then they fall apart. I'm taking a brass rod, I'm heating it, I put it in borax, which is the cleaner that's used. And the first thing you have to do is get the area hot so that both pieces are orange, and that means they'll be ready. This also helps burn off some of the scale and rust, even though I cleaned it on a wheel. And typically, when it first starts to get hot, I'll try to kiss the two pieces with a little bit of the metal. I'm going to pull it down and make it hotter. And you'll see a little sparkle, like a sparkler kind of setup. And that should tack it together so while you're doing this, it won't move on you. But the flame we want is not quite as hot. Brass melts at a much lower temperature. So we want to get I'm going to turn the light off so you can see. The lower piece is ready. It's orange. Now I have to get the top piece at the same temperature. Now what you want to make sure is that the brass will go into the joint where it's cracked. And you do that by pulling the heat back and allowing it to run through the crack and seal it. And I usually do a little bit over that, just in case. A little bit more. I'm going to go around the side and just make sure that it's sealed. Now, instead of putting this in water to cool it off or temper it, I'm going to let it cool naturally, because to me it makes it a stronger bond. Sometimes when you throw stuff in water, it'll cause problems. I think you can see that. It pretty much filled up the whole gap, even though it's black now from the acetylene gas. That's pretty good. So that should do it.